We'll get them.
Are we ready? Okay, I'd like to start off with an introduction of Fred Duennebier, our speaker for today. He is an emeritus professor in the department now. He's a professor in geophysics. I guess the story starts right about here in 1943 when he was born. You'll notice the sort of colorful plots in the background of this short resume or summary I have of Fred. These are real data for different energy sources, and this is all projections, various levels of belief or whatnot. But anyway, yeah. So Fred started off being born in 1943, and right around the 60s, he got his BS from Trinity College in Connecticut, and he did his PhD during this time, where he joined the UH faculty, and he spent close to 4 decades accomplishing a huge amount of science, including.
Garrett, did his PhD cause that drop in the oil production?
Yeah, well, I wonder.
Right, just checking.
Right about the peak in the U.S. Oil production, he was writing papers on moonquakes, one of the Apollo missions to the moon, and this is the few decades when he started doing the seismology and acoustics and marine geophysics, including putting in the Hugo Observatory on the Leahy, the H2O Observatory, and of course Station Wellcott, which is active today. These are decades in which Fred, he's noted for his leadership in marine geophysics, his pioneering and visionary work in remote observatories. These are decades of experience in learning to objectively analyze and critically interpret data. And he knows that to have a successful experiment or mission, you collect the most relevant data, plan for a number of, you make careful plans, and of course you plan for contingencies or failures. And I think he's taken that approach to addressing one of the most profound challenges humanity will likely ever face, or certainly has up until now. This is my youngest daughter, who was born just last November, and maybe she'll get a BS in a couple of decades, but her world is going to look very, very different from Fred Duennebier's world, and he's going to tell us about that right now.
I do have a sore throat. I'm not sure how long I'll last, hopefully through the end of the seminar, but that's the way it is. The talk today is Energy, Environment, and Economics, the next 30 years. Please hold your questions till after the talk. But if there's something I say that you really don't like, feel free to scream. As an outline, based on where we today, where is civilization heading? And we'll talk about energy. I always talk about energy, but I've expanded the talk to include the environment, our consumption, population, and climate, and then the economy. I'm not an environmentalist or a climatologist or an economist, but I've learned a lot in the last year, and I feel that we really need to discuss these also. Think of this truck as the Earth, and then the problem becomes very obvious. We are overcrowded, carry too much baggage, we're surrounded by a very hostile environment, and if we run out of fuel, there's no place to get more. The analogy breaks down at this point, since unlike us, the people on this truck likely know where they're going and have enough gas to get there. Do we have enough energy to get where we want to go? Can we get there without trashing the environment? Are we using the right rules to get where we want to go? Rules like exploit the resources as fast as possible, and economic growth is absolutely necessary. But where are we going? Those people on the truck knew where they were going or whatever, but do we know where we're going? If they think about it at all, if the vast majority of people, if they think about it at all, think we're on the track to continued business as usual with growth and continued prosperity. What I'll say today will give you the feeling, I hope, that that's probably not true. We'd all like to go forth and multiply and prosper, have lots of kids, plenty of food, big house, lots of toys, good education, peace, tranquility, and security. But does the earth have the resources available to continue the 20th century banquet indefinitely? Can the economy still grow? Should it grow? Do we want it to grow? If you listen to the news, you'll know that if you're a politician or a businessman, you definitely want it to grow. But is it at all a good idea? Do we see any signs of the limits of growth? Are we coming near the limits of what the earth can give us? And what would happen if the economy started to contract? These questions are what this talk is about. So let's begin with resources, with emphasis on energy and mostly on oil, excuse me. Which of these things in this picture is the most valuable? They all cost roughly $100. I'd vote for the bottle of cognac myself, but maybe you'd like the new pair of jeans or something. But actually, we all know, or maybe you should know anyway, the most valuable thing in this whole picture is that barrel of oil in the middle. It contains enough energy to move a car, a 20-mile-per-gallon car, more than 800 miles, or to do the work of a single man for more than 200 days. And for that, you pay about $100, which is ridiculously low price. So why do we complain so much about the price of gas and other energy sources? And I think the reason is because we've been addicted to it. We depend on cheap energy. We believe we have this right to have as much as we want. Do we have reason to expect that cheap energy will last for the foreseeable future? This is one forecast where energy will come from up to the year 2100. So different types of energy are on the y-axis there. The colors are different sources of energy. And the x-axis there is the year from 2000 to 2050. The orange one in the middle, obviously, if you look at it closely, you see that the fossil fuels peak in roughly 10 or 12 years, and then our energy is taken over by, what is it, wind? Solar. Well, I wonder who made this picture. I can guarantee it wasn't me. It was actually put out by, I think it was one of, there it says up there somewhere, a solar group anyway. I don't think this is at all reasonable. This prediction is based on the highly unlikely breakthroughs in technologies, including energy storage, energy efficiency, cost, raw material availability, and the ability to transport people and goods long distances with electricity. This is not likely. Here's another different prediction, going only up to the year 2050. About 40 years from now, when most of the students here will be in their 60s. And it has roughly about 1/3 drop in the amount of energy available by 2050. The huge difference between these two predictions is obvious. The yellow area in the previous slide has been called the wedge of hope by many people. And it's based on hope and dreams and magic, effectively. And it is not at all likely. This prediction implies that fossil fuels will not be replaced by alternatives. Which one is right? When you're my age, will life be like it is today? Not likely. We've heard a lot lately about fracking. Well, fracking is this process where you can drill for oil and gas going down from the surface of the earth, turning horizontal, and then effectively blowing the rocks apart so you can get at this tight oil or tight gas. The recent use of fracking to enable the extraction of oil and gas from these impermeable layers has generated a tremendous amount of hype. The hump in the supply, in that red area there, is very likely temporary, and the energy obtained is not cheap. So if you like cheap energy, this isn't going to help you any. Another problem with this figure is natural gas liquids, NGLs. They're the purple area in the middle. They're not liquids. They're liquids when they're in the ground, but it's made up essentially of light materials that are mixed in with the oil, propane, ethane, and as soon as you bring them up to the surface, they're not liquids at all anymore. And they do not replace oil as a liquid fuel. To say that they add to the liquid fuel supply is obfuscation at best. True liquid oil, suitable for transportation fuels, will never likely exceed 8 million barrels per day of U.S. production. So if you take out that purple area in there, you get a better feel for what's available for liquid fuels. At high-end estimates, predicted production from the Bakken and Eagle Ford, these are sources of oil from tight reservoirs, amounts to about a 2-year supply for United States energy. 2 years is not a lot. Hopefully, you would like to have more than a 2-year supply, but if you listen to the hype, it sounds like it's going to last forever. If you just do a quick look at the tight oil fields, the fracked oil fields, and gas fields, you see that each of these colors here, each of these small sliver triangular areas is the output from one well. And when you stack them all together, you get quite a bit of production. By the way, the y-axis here is wrong. Those are not millions of barrels of oil equivalent per day. They're thousands of barrels per day. So this is not a heck of a lot of oil. The average production drops roughly 50% per year, requiring large numbers of wells to be drilled just to keep the supply going. So you see that in this region here, these lines have negative slopes, implying that everything drilled before this, the supply is decreasing. So you got to drill and drill and drill and drill more and more, and then soon we'll be out of places to drill because these fields aren't infinite by any means. At this time, the price of natural gas is so low, the cost of fracking gas wells is so high, that companies are losing money producing gas. The reason they're doing it is because they want people to invest in it so they can make money. The incentive to develop alternatives is low because the price of gas is low, so people would like to use this gas. In Hawaii, we're talking about importing natural gas, liquid natural gas, because the price is so low. It can't last very low. The companies lose money. They've got to have the prices go up or stop drilling. Another problem with fracked oil wells is that they come up with a considerable amount of gas along with the oil. What do they do with this gas? They flare it off, which means they burn it right next to the well, because that gas is not economical to produce. There isn't enough of it to justify storing it or piping it anywhere, so they just burn it off at the site. Since the profit is so small, much of it is burned in this way. This is not an insignificant amount of oil at all. If you look at a nighttime picture of the Midwest, here's St. Paul and Duluth and Fargo, North Dakota, Bismarck, North Dakota, this whole area up in here. This is the Bakken oil field at night, and almost every one of those lights up there is a flare. So we're burning this stuff rather than use it. About 29% of the gas is burned off. The rest of it is actually recovered. What about Hawaii? What about energy in Hawaii? Most people in Hawaii have no idea, or anywhere, have no idea how much oil we consume. Here's a question for you. Anybody go to the Pro Bowl or see it on TV? How far up Aloha Stadium do you think the oil we consume in Hawaii every year would reach? Halfway, maybe to that pink-blue boundary there, up to the top row of seats? What do you think? You don't have to answer me, but just think in your head which the correct answer is. In actuality, we have to fill it up to the top row of seats. And not every year, but every 2 months. So every year we have to fill up or do the equivalent of filling up Aloha Stadium with oil 6 times. That's a tremendous amount of oil. Roughly 42 million gallons of oil every week, 1 million barrels a week. The world now consumes about 1,000 barrels every second. As much water as flows over Niagara Falls in an hour and a half. So if you've been to Niagara Falls on a good day with lots of water going over, if it flows for an hour and a half, that's about how much oil we use in a day in the world, not just in the U.S. One of our biggest problems, particularly in Hawaii, is electricity. Our electricity generation depends largely on oil. About 40% of the energy we import goes to generating electricity, but only about 40%. All the things shown in the slide depend on electricity. So what do we do if electricity becomes unavailable? So without electricity, we certainly would have no refrigeration. That's no surprise. No lights, no surprise. But what about these other things here? No elevators. If you live up high in a condominium, you're not going to get home, or at least you're not going to leave easily. No sewers. Imagine Waikiki without sewers. Not a nice thing to think about. You want money? Don't go to your ATM. Probably not even go to your bank. If they don't have electricity, they can't tell what's in your account. No gas. Why? Because the pumps are all electric pumps. No food, no refrigeration, no food. And you can't buy it anyway because they can't read your credit card. No water. Why no water? Why no drinkable water? It's because our water is pumped. We pump it up to a high point, and then the gravitational force or pull makes the pressure we use to get it out of our faucets. No cell phones, no surprise. No medical. Just about every hospital that I know about has emergency rooms and everything that have no windows in them. Medical, without the terrific amount of electricity they use and sophisticated equipment, just won't happen. The real one that causes grief for me, they all do, but this one is special, is no nuclear coolant. We don't have to worry about this in Hawaii, but we certainly do in other places. Why would nuclear go away without the electrical grid? Last year I was saying that nuclear power is likely to be the only way to keep the lights on. I don't think that's true anymore, and at the very least I don't think it's a good idea. Fukushima was a real wake-up call. This is, I think, reactor 4 going up with a hydrogen explosion. The Fukushima reactor accident was not caused by flooding. It was caused by loss of cooling. Certainly the diesel backup pumps were destroyed by the tsunami, and because the electric grid went down at the same time, it was impossible to cool the reactors. So they heated up, generated a lot of hydrogen, and finally blew. This accident could be more serious than Chernobyl, depending on who you talk to. The scary part of this is the number of similar reactors that have the same problem with the electrical grid. You would think, gee, these things are here to make electricity. What's the problem? They could just use their own electricity to cool them. I've asked this question and never gotten a good answer, but apparently they can't. They become unstable for some reason, and they need the grid power in order to keep their cooling going. Cooling ponds will also boil off eventually. When they take and replace the fuel rods in these with new ones, they put the old ones in a cooling pond. They're still very hot. And if you don't cool the cooling ponds, they will boil off. And eventually you'll get another source of radiation. Cooling ponds are not required to have diesel backup. So you're stuck with the grid in that case. If a reactor, even if it's safely shut down, it generates about 5% of the power it would generate normally operating. That's a lot of energy when you think about how much energy a one that is operating puts out. And that energy must be dissipated by heat if they can't send it out on the grid. The U.S. has 31, to my knowledge, 31 Fukushima-style reactors that would have this same problem. If we lost the grid in the mainland United States for some reason, and 31 of these took off, I wouldn't want to be anywhere around it. Matter of fact, I don't think I'd want to be in the northern hemisphere. What about other alternative sources of energy? There's lots of them, but no alternative that I know of can even come close to supplying the amount of energy required to replace fossil fuels and sustain today's civilization. Excuse me a second. My wife made this great drink for me. High-tech alternatives require fossil fuels for their manufacture. You cannot make a wind generator without fossil fuel. Shipping of the equipment from their points of manufacture to their points of use requires oil. It's got to, we have to have it. There is no replacement today for oil, or for any fossil fuel for that matter. Nearly all the energy initiatives, especially in Hawaii, when you think about the energy initiative in Hawaii, I think it's, 40% replaced by 2030. If you go to the meetings where they discuss these things, they're all talking about electricity. They're not talking about liquid fuels. They're all replacing electricity. And so little attention is being paid to replacements for liquid fuels that it's really scary. Since 60% of our imported fuels are consumed by transportation, this seems to be a major oversight. It's a real problem. Our ground transportation will likely require gasoline and diesel for many decades. It's really hard to imagine an airplane flying on electricity. I did a calculation once that said that if you use the latest and greatest batteries and put them in an airplane and flew to California, you would require more batteries than the weight of 5 of the planes that it was flying in. Not likely to happen. Compared to storing energy in fossil fuels, batteries suck. Okay, they're really bad. There are no good batteries at this point. If we in Hawaii are going to be able to cover our electrical needs with wind, geothermal, wave, solar, and other alternatives, can we be independent of foreign oil? Hardly. We require oil to get tourists here, to travel between the islands, to import our food and manufactured goods. We don't manufacture much of anything here. We'll still be required to have fossil fuels to import spares for our electric generators, heat, and to make concrete. You can't make concrete without heat. To keep the grid up, we'll require electrical storage and backups for non-baseload alternatives like wind, PV, and possibly long-term backups should the alternatives fail. Imagine geothermal if Pele decides to take out the geothermal site. It could be down for a decade or more. You've got to have the backup, probably running on diesel or fuel oil, to keep the grid up. The algal project shown here to make liquid fuels, you might say that looks real good, and it does. But look at what those tubes are made of. They're made of plastic. Okay? That plastic is made from either oil or natural gas. And it really can't be scaled up to the production needed to replace oil. To replace 5%, just 1/20th of the transportation fuels we use today, effectively 39 billion liters of biofuels, it would require about 44% to 107% of the total nitrogen fertilizer used and 20% to 50% of the total phosphorus used today. It's just plain not practical. Shipping is what keeps our society going in Hawaii. And if we're physically isolated from the rest of the world because there's no more oil, our economy will quickly become very localized. We will not be able to depend on anybody else. If we look at the sources of Hawaii's oil, the supply here, we use gasoline down here. This is distillate fuel oil, naphtha. These are all fossil fuels, jet fuel, gas and liquid propane, and this one is residual fuel oil. So this is the Big Island only, but that doesn't matter that much. So everything except those two green slices there are fossil fuels. And this was made in 2010, so it's improved a little bit, but not much. How does that energy get used on the Big Island? Well, most of it goes to transport. Is that ground transport? I can't quite see. Road transport. Aviation. But look at this big gray area here. That big gray area is losses in the electric grid. Why are those there? They're not on Oahu, at least they're there, but they're not anywhere near as bad. And I'm almost positive the reason for that is because the Big Island is big, and we have a long way to make electricity go before it's used, and the grid has losses. The other point is that we don't have any real high voltage lines on the Big Island, and the lower the voltage, the more energy gets lost in transmission. So we're not doing an awfully well here, and you'll notice that by use, we're really not doing too well. Everything in there, again, is mainly either electricity or transportation. Let me explain a little bit about how good alternatives are. This graph, anybody see the Hall lectures a couple weeks ago? Good. He talked about this term called energy return over energy invested, or EROEI. That's energy out down there divided by energy in. Energy out is the energy that's available for use by the user. Energy in is the amount of energy used to produce that material or that energy. So let's try, think of it as a tax. That red zone up there is a tax. So EROEI starts at 50 on the left side of the slide and goes down to 0 on the right side. And as we go down farther towards the right, the red area increases radically until you go over this cliff at about 5. Think of it as a tax. Think of it as something you've got to pay in order to use that energy. Try an example. Let's say we have an energy source with an EROEI of 25, and 50% of that energy right here is required to keep business as usual. So this is our background stuff. This is what generates our electricity. It makes the gasoline for our cars, whatever. This is the stuff we have to spend to keep our society going. So that leaves 46% for extras, like taking vacations, buying televisions, whatever. So 96% of the total is available for an EROEI of 25, and the tax is only 4%. Not bad. But let's say that runs out. We can't use it anymore. The EROEI drops down to 5 over here. Now what have we got? Well, it looks like we're still pretty good shape. We have 80% available. 30% of it is available for extras above what we actually need to keep the economy running. But what's happened is that the amount of tax we're paying has gone from 4% to 20%. That's a huge change. That's a factor of 5 increase in taxes. If the federal government says, oh, we're going to increase your taxes by a factor of 20, does that bother you? Yeah, of course it does. And that's what happens here automatically as you drop the EROEI. Let's look at the EROEI of renewables. Well, up here we have wind. Wind is doing pretty good. It's up around 25 or so. And solar looks pretty good. It's also pretty high up here. But all the rest of them, methanol, biodiesel. Oil today is down around 5, okay? Oil we're actually using was first drilled back in the 1950s, and it's got a very high EROEI, but the mix now is somewhere around 12 or so. Maybe it may be as low as 3. tar sands are way down there. Oil shale is way down. Corn ethanol isn't worth taking out of the ground. And hydrogen is negative, meaning that you'd have to, or excuse me, less than 1, which means you have to put more energy into hydrogen generation than you can get out of it. So why do it at all? Excuse me. We see that wind and solar might be able to supply electricity if we can build the infrastructure necessary to produce this without oil. The 2/3 of oil that is used for transportation can't be supplied by these known alternatives. Since it takes an OEI of about 7 or maybe more to keep today's civilization running, huge increases in the OEI of these biofuels and on down are necessary before we can use them to keep the lights on. And there are other problems. Wind electrical generation may be good have a good EROEI, but that's not the only important value parameter for the fuel or for the electricity. This toxic lake contains chemicals dumped by rare earth processing plants in China. This pollution poisons Chinese farmers near Baotou, China. It makes their children sick and destroys the land. These processing plants manufacture magnets for wind turbines. That's all they do. It's merely one of the multiple of environmental sins committed in the name of green. If you really look into these alternatives, almost all of them you find something like this. We've done a pretty good job of cleaning up the air and the water in the United States. We've actually improved things quite a bit since when I was small. But we've done it by exporting the air, water pollution to places like China and other countries. How are we doing at replacing fossil fuels with alternatives? Well, in Hawaii, we're supposed to be up at 40% by 2030. We're not doing too well, although the state says we're doing pretty well. These are different curves for how we use oil and natural gas, coal, and alternatives. And if you look closely at this, you see that the amount of energy being used from coal, oil, and gas is going up much faster than the energy, total energy that we're getting out of alternatives. We are not doing very well. This graph shows, it's very similar to the one that Garrett showed. Even got my birthday on it down there. This graph shows the amount of oil consumed per year versus time, and that is per day. Oh, I'm sorry, it's billions of barrels per year. In 1943, the world consumed about 5.8 million barrels per day. Doctors made house calls, and milk was delivered to your door. Sounds pretty good. Between 1943 and 1954, 10 years, the world consumed more oil during that period, 10 to 11 years, than in all time previously, consuming about 14 million barrels per day in 1954. During the next 10 years, same thing. They consumed more oil than had ever been used previously. Same thing in the next 10 years. Between 1974 and 1989, again, they consumed more oil than in the previous whole history of the Earth. You'll notice that this one is now about 15 years instead of 10 years, so it's slowing down. The rate of increase has slowed, but we continue now to burn about 75 million barrels per day, 1,000 barrels a second, 10 times what we consumed when I was a kid. How long can this go on? If we look at the blue curves in here, these are when oil was actually found in the earth. And the red curve is how much oil we're using. And this is billions of barrels per year. You notice that the peak in the finding of oil was way back in 1960 or so, 1965. And it looks like we're getting real close to the peak in using it. The area under the blue curve, the area under the red curve, when they're the same, you've used everything you've got. When the area under the red curve is half of the blue curve, you've used about half of the oil. We're pretty darn close now. You'd have to do a lot of smoothing, and it'd be nice to know what the rest of the curve looks like, but we're pretty close to what's called peak oil, that time when we've reached the maximum usage that we can. Note that there's about a 40-year delay between peak of discoveries and the likely peak in production. We're pretty close to that now. We've picked all the low-hanging fruit. We've picked all the easy-to-get oil. What's left is poorer quality. Things that people would never have thought about drilling before, like tight formations or tar sands. Everything is in smaller reservoirs, harder and harder to find, harder and more expensive to produce. Instead of drilling it from Pennsylvania, now we have to go to the high Arctic. And it's much more expensive. As oil supplies dwindle around the world, producing countries will hoard their oil. If they think somebody else wants to buy it and they don't have enough for themselves, instead of putting it out on the free market, they'll just keep it. And that'll then decrease the amount of oil on the market, and it's going to hurt everybody who imports oil. Even if fossil fuel supplies were infinite or close to it, could we keep going with business as usual? Well, let's look at the population and the environment. Talk about hockey sticks. This is the world population growth throughout history, beginning about 2.5 million years ago. Before agriculture, the carrying capacity of the Earth, which is the number of people that the Earth can support sustainably, was about 100 million. Why was it so low? It was limited by the resources they could use. They didn't have the technology to either find or burn fossil fuels, at least not in any kind of a quantity. And so they were limited by energy available, and mainly by energy available in disease. Development of agriculture and the transition from hunter-gatherer civilization provided food security and and the barriers to population growth went down. World population will have shot up from about 1 billion to at least 8 billion and possibly 11 billion in this window of time between 1800 and, say, 2050. That's a huge increase. With the discovery of how to utilize fossil fuels, we won the lottery. Okay. It's just a huge amount of energy that suddenly became available. And the limits of growth appeared to evaporate. Anybody who talked about limits of growth was laughed at up until, well, it still is true, but when the Limits of Growth, the book, was published in the 70s, they were literally laughed at. As we reach the limits of growth, the exponential curves will peak and start down. With the end of cheap fossil fuel, the carrying capacity of the Earth will likely drop like a stone. Consider food. Before the Industrial Revolution, food supply was limited mainly because the only energy available to farmers, whatever, was maybe an animal or two and human muscle power. The number of people that could be supported by their own energy was very limited, so we were stuck with just a limited amount of food. With the Industrial Revolution, that improved. Look at the bigger picture down here. That's a 27 horsepower combine harvesting sheep. Literally 27 horsepower. Got a great piece of machinery there, but they could not use oil yet. Today, that device there too, that old combine, required 8 men working on it, 30 plus horses, including spares, feed for the horses, whether they were being used or not. So this was a very expensive way to go. with the knowledge of how to use fossil fuels, it became possible to replace muscle power altogether and make machines like this 200 horsepower harvester up here at the top possible. It only requires one human, and you don't need to feed it when it's not being used. It's machines like this, coupled with knowledge of fertilizers and biology, seeds, that have made this, it made it possible to feed the 7 billion people. But can we keep it up? Can we have another green revolution? While we've been increasing the amount of productivity of our farmland pretty steadily, it's now starting to roll off. And the price is getting higher and higher. Since about January 2001, the price of food has gone up by 2.5 times, 250%. That makes it very hard to feed somebody who doesn't have the money to afford this. If we look at other things that we consume, well, there's population there again. These all go from 1750 to a little after 2000. So population has gone up pretty much exponentially, and it is showing signs of slowing down. Water use is still going up exponentially. CO2 concentration in the atmosphere. Number of cars, very exponential. Fertilizer consumption is peaking. You can see that the peak is now getting jagged. Loss of rainforest, still exponential. Paper consumption, pretty much still exponential. Number of fisheries that are at their limits, getting higher and higher. Now it's up to about 80% of all fisheries in the world. Can we double again? Man, really seems very unlikely. Let's look at climate. 13,950 peer-reviewed papers on climate were published between 1991 and 2012. Can you see that little red sliver up there? Those are the number of papers, 24 papers, that said climate change isn't occurring. Well, if you'd rather believe Rush, who says climate change is a hoax, go ahead. But I think this is much more likely to be the truth. Only 3% of the peer-reviewed papers that are published in this period deny an anthropogenic change in climate. In other words, they say, yes, the climate is changing, but we didn't do it. Okay. But only 3% of the people say that. Models forecasting climate change aren't perfect or complete because we really don't understand the nonlinear feedbacks and effects of what's going on. But the models are certainly ominous. This is the scariest slide I'll show. If it hasn't been scary enough for you yet, this one should do the trick. Forecasts of average global temperature increase are changing as the models improve. But the forecasts only get more and more alarming. These aren't guesses by charlatans. These aren't people who, like me, who look at climate once in a while. These are the people who study climate. These are the most respected climate groups in the world. And if we go over these a little bit, the IPCC, the International Panel on Climate Change, in late 2007 said we expect 1 degree C by 2100, 1 degree above what it was in the before the Industrial Revolution. We're at 1 degree now. Hadley Center for Meteorological Research in late 2008 said 2 degrees by 2100. UN Environmental Program, mid-2009, 3.5 degrees by 2100. Hadley Center for Meteorological Research in 2009, 4 degrees by 2060. Global Carbon Project in Copenhagen, 2009, 6 to 7 degrees by 2100. That's a huge increase. International Energy Agency, the IEA, US government agency, November 2010 said 3.5 degrees by 2035, and then they changed it and said, well, maybe 2100. United Nations Environmental Program, December 2010, 5 degrees by 2050. In the IEA, again, International Energy Agency, early 2012, up to 6 degrees by 2050. 6 degrees centigrade, 10 degrees Fahrenheit. The IPCC panel on climate change had a leaked document that's supposed to come out later this year where it said there's a strong possibility of 9 degrees centigrade by 2300. Long ways away, but 6 degrees is really enough to pretty much end what we know of as the world today. So if these predictions are correct, we're in really serious trouble. Lots of physical problems. The degrees in centigrade are down below, and it doesn't even go up to 6 degrees. But they see large increases in species at risk of extinction. See, everything gets much worse as the temperature increases. So what's going on? Can we do anything about this? Here's another example. From 1900, the scale on the bottom goes from 1900 to 2100, and this is ice cover during September, Arctic ice cover during the month of September. The models are the black curves, data are the red curve. So we were right on because that's when we started taking data. But where we are now was not predicted to happen until 2050 or 2070 or so, about 50 years from now. So it's happened 50 years early in a projection that lasts 100 years. So what's being done? We haven't been told very much about this by the government. Certainly nobody's made a point of it. Certainly not by our politicians. So this cartoon says, and so while the end of the world scenario will be rife with unimaginable horrors, we believe that the pre-end period will be filled with unprecedented opportunities for profit. My wife put a little whiskey in here. Boy, I need it too. So what's going on? What's happening? Let's look at inflation here. Here's a 1964 quarter on the left and a 2008 quarter on the right. In 1965, they had the same value. They could both buy the same amount of material. Nobody cared. Today, however, the quarter on the right will buy you 20 minutes of parking in the Kaimuki parking lot, while the quarter on the left would buy you 9 hours of parking time if you used what it was totally worth. So it's about 27 times the value of the new quarter. 27 times. So an inflation of 27 times, that's 207, no, it's more than that. 200, what is it, 2,000? 27, well, it's times 27 anyway. Silver is intrinsically valued. The one on the right is made from junk metal. The one on the left is made from 90% silver. And that's why there's a big difference today. But the point is there, 270% inflation. That's huge. But we don't even notice it. Why? Because we deal with quarters. We don't deal with silver so much. So why did this inflation occur? Is it serious? Well, there's another one of these hockey sticks here. This is the rate of inflation, or actually the price levels. Starting at 1700, inflation rate was roughly 2%. You notice that those little spikes in there happen at times of war. Okay, so why would inflation incur war? Because you're spending a lot of money on things that are effectively worthless as soon as the war is over. Civil War, World War I, World War II, Vietnam, and then it just takes off. The rate of inflation just went crazy. Why? Why did it take off? Is inflation under control? Sure doesn't look like it, does it? That actually goes out to 2000. Okay. When you get a bank loan, the bank enters a liability into its books for the value of your loan. They also enter an asset into their books for your promise to repay the loan with interest. What's the net effect of this? They're making money. Just by the fact of loaning money, they're making money. Our current economic models require growth of the economy, and in order to get growth, you need money. Loans are made to pay off the debt with the assumption that growth of the economy will supply money to pay off the debt. Let's look at an example. This is crazy to me, and if somebody sees anything wrong with this argument, please let me know. But if you deposit $100 into a bank account now, the bank can legally loan about 90% of your deposit out. So they don't need to save your $100 or anything. So you could borrow that $90 and put it back into your bank account. And then you could take 90% of that, $81, and put that back in your bank account. Loan that 81, put it back in your bank account. So eventually you could have over $900 in your account, and you only put $100 into it. Okay, I'm leaving out the interest, right? But at times when the interest is very low, this is a good investment. Is the rate of inflation under control? I'm afraid not. This is CPI, or Consumer Price Index, versus time starting in 1981 and going to 2011. Consumer Price Index is a measure of inflation. Well, one of the problems is there's two curves here. There's a red curve and there's a blue curve. The one the government will tell you the rate of inflation is about roughly 2 to 3% is the one the government gives you. But they've cooked the numbers. That means that they've actually changed the way they calculate the numbers to make inflation look low. Why would the government do this? Why would they make inflation seem less than it is? And as near as I could tell, the reason is that inflation appears in the denominator when you're trying to look at the gross domestic product. So by decreasing the amount of inflation, you're increasing the gross domestic product. You're making the economy look good. Here's an example of the way this basket of products was at one time. You'll notice the biggest thing to notice here is that shelter is that blue area at the bottom. Transportation, not including fuel, is that brown area. Where is energy? Well, there it is. It's up there in the green area, 10%. So what they're saying is that the cost of energy is only 10% of what it costs to do business, what is included in the Consumer Price Index. I don't know if this is realistic or not. To me, it seems crazy. So what that really says is that if energy raises the CPI by about 1/4 of the cost of housing, so if energy goes up by a factor of, say, 100%, then it's actually treated much less than, say, housing or apparel. No, apparel is less, excuse me. So how are we doing? How's the government doing? Oh, here's another one of these exponential curves. Government debt. In order to pay off debt, the government has to borrow money. If you ever did this with your credit card, your debt, your credit rating would drop like a stone. This is ridiculous. I'm not going to have to pay it. But a lot of you kids are. You're going to have to pay the bills. Most conventional economists thought that even a rise in average global temperature of 6 degrees C, which I think would pretty much kill off most life on Earth, is equivalent to the scale of change from an ice age to an interglacial epoch in 100 years rather than in thousands of years. And it would have only a few % impact on the world economy, according to these economists. In essence, they accept the paradigm that society is almost independent of nature. These are the people who make the models that our government uses to develop policy. I'm going to run a bit late, but not too much. Problems have rational solutions. By this definition, predicaments don't have rational solutions. Do we have a problem, or are we in a predicament? Before the Titanic hit the iceberg, it had a problem. And it only needed to turn away before it hit the iceberg to be saved. Unfortunately, that problem turned into a predicament when they hit the iceberg. And a failure to recognize the risk and the lack of planning, like having enough lifeboats, caused the deaths of more than 1,000 people. Humanity now has a problem. But we're really taking a course that puts a slammer right into the middle of that iceberg. Why are we being so stupid? Do we have a problem or a predicament? What's the likely result if we stay on this path? In the next 30 years, a lot of things are almost certainly going to happen. The end of cheap energy leads to an accelerated resource scavenging and ecosystem destruction in a desperate attempt for survival. The cost of mitigation of environmental destruction will become unaffordable. So people talk about, oh, we'll use clean coal. I don't believe it for a second. Clean coal is expensive, and the companies will just say, well, if you want us to use clean coal or make clean coal, you're going to have to pay for it. And we won't pay for it. Customers demand the cheapest energy possible and would rather pay now rather than recognize the problems they're leaving for the future. Resource depletion. Growth of human population and consumption is degrading resources. This could lead to contraction of the economy, collapse of the financial systems, and collapse of governments. We don't realize how well off we have it in the United States. This is something that actually happens. People would think we were crazy for going to the toilet using potable water. The end of growth. We can certainly expect the end of growth as we run out of resources and they get harder and harder to get and more expensive. To get elected today, a politician must support growth. We all know this. Just look at the paper, listen to your nightly news. The economy must grow. The number of tourists must grow. We must have more jobs. We must grow more food. We must need to produce more energy. The survival of our civilization actually requires just the opposite. This is crazy. We'll almost certainly see the end of long-distance transport. Most of what the manufactured goods they sell in Walmart they come from long ways away. They won't have any way of getting here as oil gets more expensive. So we would like to have products made in a more environmentally sound way, and we want our own citizens to be employed. So we need to make our products locally. Our own oil consumption is dropping, but that oil is being used by China and India to make cheap goods for us. Cheap trumps everything. When the capacity of cheap energy drops, carrying capacity decreases and overshoot ends. This graph shows consumption on the y-axis and time on the x-axis. Carrying capacity, again, is the number of people that can be supported by the world. And it was pretty steady for a while until we started to have more and more people. Now we have overshoot, and it would take about 1.5 Earths to support our current population. Since we don't have 1.5 Earths, the population has to start to decrease. And as it does, as our resources go, the carrying capacity will also go down. So we have decreasing population, decreasing consumption, decreasing carrying capacity. We can look forward to disintegration of infrastructure. Concrete and rebar, for example, will deteriorate rapidly when not maintained. Maintenance of buildings, roads, bridges, sewers, and water mains will end because we will not be able to afford to use the trucks, the diggers, whatever, to replace these things. Imagine our water supply on Oahu if we stopped stopped repairing water mains every week, we wouldn't be there for very long. Okay, what should we do? We should end pollution. We should end growth, reverse growth. We should stop using fossil fuels now. Reduce the population, reduce energy use, conserve everything, clean the atmosphere, use alternative energy sources. None of these things are practical, unfortunately. And if you're a politician, good luck getting elected with this platform. We have no humane or acceptable way to accomplish these goals. We seem to be accelerating on a track leading to disaster. In my mind, this is certainly a predicament, not a problem. There are no humane solutions. What can you do? You're an individual, you're not a government, you're not a country. What can you prepare for? Well, you can prepare for sharp reductions in the amount of energy available. There won't be enough food for everybody. Grow your own, or get in a community that grows its own. Reduce your dependency on government. You'll have a loss of long-distance communication and travel. Local resources are going to be the only ones available to you, no high tech. If it doesn't come within 50 miles of where you are, you won't have it. You can promote local community action, secure food and water supplies. Learn how to live without blank, just about everything. Learn how to grow food, learn how to use junk. Probably the most important piece of junk there will be 30 years from now is all those cars. Okay. You won't be able to use them for what they were intended for, but there's a tremendous amount of useful stuff in them. You should start collecting tools, books, trade goods, things that you can actually use. Here's some for the geologists. At the end of the day, it's all about economics, according to the economists. But at the very end of the day, economics is all about geology. Geological and biological resources have been exploited beyond the carrying capacity. We've used up the cheap and easily exploited resources and are about to pay the price. The oil paradigm shift and running out of everything argument is very bad news. And like all very bad news, ordinary mortals and the bullishly biased financial industry seriously want to disbelieve it or completely ignore it, just as they do with climate change. Good luck to them. And good luck to you. We're out of time, so mahalo. Thank you. What do you want to do with questions, Rob? Shall I use my mic?
Okay, Fred, I respectfully request to disagree with you 100%. I would disagree with you more than 100%. But see, you have asked us in the beginning that we should not interrupt you before you stop. You have now stopped, but it was very hard to listen to this. I disagree with almost everything you said. Now, I'm not ready to deliver a counter talk to yours. Also, we have no time. You over did the time already. But I just wanted to say I disagree 100%. I think we can have a much better future than you think. And again, you know, there's no time now to even talk about it.
I'd be very glad to sit down with you and go over your reasons for thinking that way.
Yeah, well then
I would love to have somebody say, not more than say, but prove me wrong.
Yeah, well,
gee, it would be great, but I just don't see it.
I think is provable as incorrect. And again, I don't have a counter talk in my pocket here.
Well, you're not alone. Prepare one, somebody said. You're not alone, of course. I mean, but I think you're wrong.
Business as usual will indeed result in some of the things you are predicting, because we do have a finite earth and finite resources. Every geologist knows that there is a limit to how much metal you can take out of a mine. And if you mine it with a philosophy of always taking out the lowest grade possible, the mine lasts a long time. If you take the high grade out first, the whole thing goes bust very fast. What we've done with our fossil fuel supply is we've taken all the easily exploitable fossil fuels and we have mined them in a century.
Right.
And that was not a wise philosophy, but it allowed 4% compounded growth. And that's what we all wanted. I gave a lecture on growth to the Planning Commission in LA County a while back, and they couldn't believe that their jobs disappeared in 10 years' time because there is no more rural county. It's all urban by then in 10 years' time. And they couldn't believe that they had no function anymore because they didn't understand the rule of compound growth. The last doubling you don't see coming, and the end occurs most of the way through that doubling. And that's the problem I think we all face. We don't see the shortages coming, and once the shortages start, it's very, very hard to reverse. And I just differ with your definition of peak oil. Peak oil is the time in which your production capacity peaks. You may be well past the halfway point.
Possibly, but I don't disagree with you. By the way, this is Lorenz Megart, who was chair of oceanography a long time. This nasty guy here is Chuck Housley. He was the head of the Hawaii Institute of Geophysics for many years, and he's the one who got me interested in this.
But I will offer to give the crowd an alternative that is a solution if you want to listen to fusion later on.
Other questions? I have to get close to you, so don't think I'm leaning on you. Steve?
Fred, you've given this talk now for several years. This is the first year, I think, that you've said 30 years from now we're in trouble. What changed in the last year so that you said you assigned a time for when things hit the fan?
I think it could happen tomorrow. The reason for that is that if the Arabs decide to block the Straits of Hormuz, or if the North Koreans decide to bomb Tokyo, things could go south really fast. But I can't see things being the way they are now 30 years from now. So I haven't really I put kind of an outer limit on it, but I'm not saying that things will go south 30 years from now.
Okay.
I'd like to find out, where are you putting your retirement money?
Where am I putting?
It's important because where you put your money is really what you really believe.
I can tell you what I'm doing. We are selling our nice house up on a hillside, and we're moving into an apartment temporarily, and then we will buy a lot which we hope to farm out in the country. But that's no guarantee. There are no guarantees.
What about the retirement funds to buy the...
Mostly real estate type of things, yeah. Jonathan.
Hi, Fred. So a lot of the suggestions you made for things that we should learn are being practiced in rural communities in third world countries, some of which have their own oil and gas production, and some of that's not being provided to international corporations anymore. How do you think people in those countries will fare? Because you also talked about a grab for what's left. Do you think that rural farmers will be able to survive in small pockets?
Oh yeah, I think so. I hope so.
I guess
but again, there's no guarantee. Another thing that's happening now is that countries that don't have much farmland are buying farmland in Africa and other third world countries. Something like, what was it, 5 times the size of Great Britain is now being leased by well-to-do countries from countries in Africa to grow crops on. Whether they like this, the local people usually don't like this, but the governments do because it gives them money.
tomorrow where we're going to go back to a simpler way and not have all the expenses that we do in terms of energy and overgrowth, how long would it take the Earth to come back down to the 1950 level and recover on its own naturally, even if tomorrow you could stop everything we're doing?
I don't know. It would be because of climate change. I used to think that climate change would not bother us until well after the oil situation, the energy situation hit us. But now, looking at the latest predictions, I think climate change could very well hit us at the same time, which means a huge problem, predicament that could take centuries to come back. And even then, we won't have the energy we have today.
So in one of your slides, you had an image from a book about the transition movement.
Oh, yeah. Mm-hmm.
Okay, so transition, basically confronting the challenges of peak oil, climate change, and financial instability. And I just thought I'd throw out for folks that we do have a transition Oahu here on the island. It's just getting close to 2 years old. We need folks' intelligence and energy, but I think it's a way of positively looking at where we could go when we try to get out of the predicament we're in. It'll mean changing the way we live, but it also means building closer relationships and resiliency as we go. So transitionoahu.org, there's a Facebook page. We're looking at complementary currency, food forests, etc. So I think it's a good way to plug in.
I agree. Thank you for that, because there's no way we can all do this on our own. We need to be in communities of like-minded people.
That sounds like being very proactive, but my study of economics says something different. My study of economics says there's going to be a big depression.
Oh, I agree with that.
The only way that we change major economic principles is a big calamity. And the last one we just had, if you think that was bad, that was nothing.
You won't get any arguments from me. I'm sorry I took so long.
Okay, well, thanks a lot, Fred, for